Okay, so yesterday we did a lot. Y'all got, a whole math class of notes and new stuff and everything, so it was a little bit much. All right, expressing roots. We talked about how they can be positive or negative. We talked about we talked about the number inside is the radicand, that's the radical sign. If there's a negative on the outside, that means you'll get a negative answer. Okay? If it's on the inside and it's even root, it's not real. Remember, if there's no number inside the little check sign, as we called it, we're going to assume there's a 2. So we're looking for a number that times itself only 2 times will give you the radicand. Okay, and then we talked about cube root. If there's a little 3 there, that means what number times itself 3 times will give you the radicand. Okay, nth root, we talked about that, it could be 4 or 5 or whatever. Here's an example if the root is 4. So what number times itself 4 times will give you the radicand, which was 81, and the answer was 3, because 3 times itself 4 times gives you 81. All right, we talked about an even root is not with a negative. So if there's a negative as a radicand and an even root, then it is not a real number. Here's another example. If it's 4, negative, not a real number. If it's an odd root, then it is a real number and we got to figure it out. So if it's an odd root and it's negative radicand, then we know we can do it. Okay? This is real, odd, negative, negative 2, negative 2, negative 2. All right, then we did exponential and radical forms. Okay? Which I don't understand, is one of those I don't understand why they didn't do 2 different sections on this, because this alone is not bad, but it's just one more thing you've got to learn. So anyway, exponential looks like this. The denominator is your root, and the numerator is your exponent. It can be written like this or this. It's normally like this. Again, here we have 8 with the exponent of 2/3. So the 3 is your root and the 2 is your exponent. Okay, and let's see, we did that. Here, we remember we talked about we have to get the denominators to be the same as if adding fractions. So now the root, the denominator is same, that's going to be your root, and then we just apply the numerator to each of the terms inside the radical sign. So do we remember all this stuff? All right, let's get started. Examples.
Page 433.
Isn't it 435?
Yes.
All
Yeah,
right.
it's close.
All right.
Close.
So let's look at number 1. It says, let's see, Keith, read the directions, please. All right, so number 1, square root of 49. Now, again, we need to stay focused as to, wake up, New. We need to stay focused as to the check. There's nothing in there. So what do we pretend is there?
2.
We can pretend that there's a 2, but y'all don't even really need to write that. So, Keith, what would be the answer? What's the square root of 49? Very good, Keith. And that means it's 7 times 7.
So that's the answer. 7 is the answer.
7's the answer. All right. Look at number 3. Negative square root 36. Sophia. What? Okay, I can't understand you when you whisper. Be confident. Give me your answer. Yeah, at lunch. Be confident like at lunch.
Yeah.
Whatever that means.
Yeah.
Yeah.
What is
Stare
it?
at her while you say
Is
the
that
answer.
a real number or is it like -6? I don't know. It's like it's on outside.
That's right, it's on the outside. So look at the very beginning of our notes.
-6.
Very good. It's -6. Okay, so what got you was this negative, because if it was -36 and the root is even, which would be 2 here, then that is not real. Okay? So if the negative is on the inside and the root is even, 2 is even, then it's not real. But on the outside, that would make that -6. Does that make sense? Because -6 times -6 is
36.
positive 36, which is that.
So we're only focusing on what's in the inside.
Well, we got to focus on that too. But yeah, basically you work this out and then apply that. So, someone in here said something like distributive property kind of thing. Who said that? You did?
I think new.
Did you? Oh my gosh. Yesterday, something like distributive type thing.
That was me.
Was it? Okay, it doesn't matter. It's kind of like that. You solve this, and then you distribute or apply the negative sign. All right, any questions so far? All right, number 5. Square root of 49 over 16. Ariel, you want to take a stab at it?
Would it be 7/4?
You are absolutely correct. Good job. So check that out. Don't let the fractions inside there scare you. Okay? I just got through teaching 7th grade this. If they can handle it, you guys can too. So you just kind of pick it apart. Okay, well, that's a perfect square right there. 7 times 7. And then that's a perfect square, 4 times 4. So that's it.
Can you take it out of improper fraction?
Improper fraction? No, you just leave it like that. I mean, you can, I guess, but you don't need to. All right, 7. Oh, this is fun. 0.01. Square root, yeah, man, there's decimals. Keith? No? No. Okay. Who would like, put your calculator away. That's cheat, no.
I'm saying something.
I want the calculator gone. No. No.
Why
No.
don't you take it
No.
from him?
Away. Thank you, sir. Chap.
0.1.
Very good. Now, boys and girls,
Wait, what's the difference?
0.01, 0.1. Now, guys, if decimals are not your thing, do not grab a calculator. Okay? It turns your brain to mush. If I don't like decimals. So you know that there's going to be an answer, first of all. Okay? Because there's no prime or anything right now. So then just start playing around with it. Start saying, well, just start multiplying 2 things together to see what you get. 1 times 1 is 1. 0. Go to the next thing. 0 and 0. And you get 0, 0, and 1. So then how many total places? 2. Move it over. Oh, I didn't do that right. What did I do wrong? Oh, yeah, I did it right. Okay. So then it goes over there because there's 2 total places behind the decimal. So then there's 2 places behind the decimal there. And that checks. You're just going to have to play around with it. There's not a whole lot of decimals, but you're going to see them, okay? Don't be scared. You can moan and groan, but do not be scared. All right, 9. Square root of negative 196. Morgan.
Mr. Rogers.
It's going to be that kind of day. Answer the question, please.
Okay. I believe. Is it 13? 13? Is it 13? No.
I don't know. Try it out.
I don't. It's fine. No, it's not. Yes. Yes. No, it's not.
Are you thinking of 169 or something? Nothing. Just keep working it.
Okay, it's not 12.
This is awesome.
Yeah, actually. Wait.
I knew I
think
chose the right
multiplied-
person.
I think I multiplied the 13 wrong. See, I did.
Yo, it's not.
Shh.
Oh, shut
Why, Keith? Why?
I didn't know. I didn't see her to listen to this. This is South Morgan. You supposed to
Oh,
know.
rough
You're supposed to
day,
know
Miss-
this.
Morgan, there's a
It was
negative.
a rough
He is
day
out of-
yesterday.
And
I don't
what's my root?
2, but it's not real because there's a negative inside. I thought that was strange when I saw it.
Yeah. 13 times 13. It is not real. Because there's a negative and an even root. Man, I chose the right person
You did.
for the job. This was awesome. Thank you, Morgan.
You're welcome.
Okay. Do we understand why it's not real, boys and girls? Keith,
Yes.
you ruined it.
You
It ruins the show.
This was sad.
All right. Let's see.
Honors.
Miranda, now that you're not coughing anymore.
Oh,
Oh, this is going to be challenging, Miranda. 2 times 2 does not give me this. Ah, very good. She's correct. Because we need to know what number times itself. What number times itself 4 times gives us the radicand? And the answer is 2. Very good. Let's see. Oh, 13. Morgan, do you want to redeem yourself?
Let's do it. Okay. And negative 27 inside the checking mark box thing.
Yes.
That means it's a faker.
Wait, what do you mean it's a faker? Explain that to me. Are you trying to tell me that's not real?
It's not real.
Morgan,
Look at
no.
There's a 3 there. There's a 3.
So if it's an
Oh my
even
God.
root in the checky thing,
Right. I
And
know,
we have
I
a
can
negative.
Explain this to you.
but here it's
No.
odd.
It's an odd number, so that means that you can have a negative in the middle.
It
The
is
answer
real.
Listen,
It's
negative
3.
Shut up.
So
Negative 3.
thank you. She's
Yeah.
correct.
It
Good
is
job.
real.
So shh, Keith, be quiet. I asked you to do this one right here, and you said no. You didn't even
Yeah.
try.
No,
All right.
I didn't.
So.
then redeem.
All right, so negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is a negative 27.
You know, if that was a 2, I would
I'm
be
gonna-
spot on.
You know what, though? Morgan is helping to drive this home to you guys because I guarantee y'all going to remember all of this.
Mhm.
All right, let's keep working. 15. Ooh, look at that big old check thingy. With a root of 3, 125 over 64. Keith, you want to be my victim?
5 over 4.
Very good. It's 5 over 4. Because we're looking for what number times itself 3 times gives us 125, and what number times itself 3 times gives us 64. So it's 5 times 4, 5 times 4, 5 times 4. Now, boys and girls, they're getting these kind of fast. Some of you, it may take a while. You may have to actually, think and play around with it. But again, when you have these fractions, I would stop and look at each one separately. Okay? Don't try to do the whole thing together. look at the numerator first and say, okay, there's a root of 3, so what number times itself 3 times gives me that, and so on. Be careful and don't sit there and say, oh, that's a perfect square. Remember the root. That tells you. It's very important information. Okay. Oh, yeah, I like 17. I want to volunteer to tell me what they think the answer to 17 is. Tell me if you have an answer. Franz?
74.1?
No.
No, 74.6.
Okay. No. You want to pass?
I want to pass.
Okay. You do want to pass? Okay, Morgan. I thought you said you knew.
I thought I was gonna say 22, but then I realized that the
Ariel?
exponent was there. What did? I'm doing that.
Do we since you're what's it called? I'm forgetting everything. Why am I forgetting?
I think you're on the right.
Okay, since you're squaring it, wouldn't it be the number that it already is?
So what's your answer,
So it
Ariel?
would be 1492.
It is 1492, boys and girls.
What's that here?
What?
Did you write it in blowing with it?
Your 17 on page 435 does not look like that? Oh my gosh, be on the right page, Sophia.
How the heck did you get that?
Okay, so watch this, Miranda. If I have this, what is that answer? Okay, because it's perfect square, right? 7 times 7. What if I have, wouldn't that be 49? What's the square root of 49? Bingo.
So what's the point of that?
Okay, let's try this. What is that? Okay, so let me write it another way. What if I do this? What's 4 squared?
16.
What's square root of 16? See? All we're doing is the square, right? It's a perfect square. So 4 times 4 is 16. Well, the square root of 16 is 4. So if I were to, let's pretend I'm squaring that. And my handwriting is terrible. If I were to actually figure it out like I did here, I think it gives me this. I don't know. I think that's like an 8 or something. 4. And then you'd have to find the square root of this, which would be,
Oh. Okay.
That's the year Columbus sailed the ocean blue. In
1492.
yes. There's no, it's not a coincidence they put that in there. It's a bunch of old people that design these books. Do you get it now? Does everyone get it?
Yes.
Okay. Keep on moving. Last page for this section. 19. Okay, 19. Notice this one too, boys and girls. 1776 with a cube. Okay, who would like to guess this one? New? That's
the year we got independence.
very good. Because the root is 3 and the exponent is 3. That means this times itself 3 times is going to give me whatever that actually is.
So what's the point of the 3 in the check?
They're just trying to, because we want to know this,
So those 2 3 mean the same.
pretty much.
They cancel each other.
It's like a perfect cube instead of a perfect square. This is a perfect square because it's 4 times 4. That is a perfect cube. Like this would be a perfect cube. When I say perfect, that means there's no remainder. And we'll be getting into that in this section. Not one, but later. All right, let's look at 22. Oh, I don't like that. We're not going to do any of that mentally estimate, none of that. No, forget that. Okay, we're going to go down to 31. Yep. Don't worry about that mentally whatever. That's so dumb. I guess I should teach it. I don't care. Okay, I'll show you.
What?
Look, just look at 22. I'm not going to sign it, but I want to show you why I'm not wasting my time. Is this a perfect square, boys and girls?
No.
Huh? Yeah, write it down. So there's no number times itself going to give you 75, right, Keith? Excuse me? Say yes, ma'am. Thank you. So what number can we do that's closest to it? Like, what's the closest perfect square?
9.
Okay, so 9 times 9 gives us 81. That's a little above that. So let's try it. What's 8 times 8?
54.
All right, so which number, 64, 81, is closest to 75?
81.
Talking about there's no like one number
Bingo.
that's gonna like
So that's your answer.
That's stupid.
what?
Okay. If you read the directions, it says mentally estimate each root. That's why I don't waste my time with this. Because, well, for obvious reasons. Y'all figure this. I'm not even gonna take notes. Y'all understand that? Okay, let's move on. Let's look at 31. You better be taking notes, Franz. 31. Okay, this time it says convert each radical to exponential form. So that's important. We're converting to exponential form. So 31 is the square root of 3x cubed. So, Franz, you want to tell me how to do this?
So an exponential form would just be 3x cubed, but then you have to get the cube out of the way, so it would be 27x.
No.
I really know this one.
Okay, Morgan.
I'm for sure. First, you put, there's nothing in the checky box, so you put a 2 right
Ah, very good. There's nothing there, so we're going to assume there's a 2 there.
there. The checky box? The
Yes,
checky
it's
box.
okay. Go ahead.
And first you put the 3, and the number in the checky box is the denominator. And then 3 has the imaginary exponent of 1,
So
And
then
then-
it's 1 over.
2, and then times x, 3 over 2.
Perfect. And that's your answer.
If they didn't have the same denominator, would you have to
In this case, they will because the denominator is going to be what's in Morgan calls the checky box. Okay, the root.
I
That's
dubbed it.
okay. So the root will always be the denominator, so it's always going to be the same. It's when you're going the other direction that you have to get same denominator. Look at 33. Now,
This
do you
one.
want to do this one?
Yes.
Okay,
I understand it.
good. So we have a root of 5 and 3x squared y cubed as the radicand.
Equals 2. So 3, and then 1 as the numerator, and 5 is the denominator.
Good.
X, 2 as the numerator, 5 is the denominator,
Perfect.
and y, 3 as the numerator, and 5 is the
Do-
denominator.
Very good. Do any of these need to be simplified?
No.
And you're correct. Good job.
This is gonna be an awesome YouTube video.
I know.
on your thing.
Okay, next section, and then we're going to be about done. It says convert each exponential expression to radical. So now we're going the other direction. So 35, it is 3 and a half as the exponent times y to the half exponent. So let's see. Valeria, This time they want you to put it in radical form. So I'm going to go ahead and draw my radical sign, and you tell me what to do and where to place it. Okay. To outside where? Like right here? In the checky thing. All right, so your denominators, are they the same? Are your denominators right here the same? Yes. Okay, that's an important thing to make sure of. You have to make sure your denominators are the same. So where does the denominator of both of these things go? In the checky thing. She's correct. And so now what do I write? Just y, correct? Is that correct? You're correct. Do I need, now see these numerators are 1. Do I need to put a 1 right here? You can't. What's going on?
Somebody's getting in trouble. Big trouble.
In big trouble.
I thought it was Mr. Bean. I was like,
Oh, he was just in here bragging about his class too. That's sad. Okay, this is the answer, but you can also write it like this. Are y'all sure someone's in trouble?
Oh,
Oh yeah.
He's yelling.
he's
He
yelling.
was
Yeah.
saying,
He's mad.
You don't talk to me like that in a very
Did you
loud
watch it?
voice.
Oh, no. Okay. I'm still recording, so we have to move on. Okay. So either one of these is acceptable. Do y'all see that? You don't have to write the root because it's implied, but it's there. Ooh, okay. No, I do too. Okay, 37. He really was. This is sad. He was literally in here at lunch bragging about how great his class was. Huh? The 6th grade, yeah, he loved them. I mean, he's just going on and on and on. All right, so 7 to exponent of 1 over 6, a half, and then b, what is that, third? Okay. So, Franz, you've already done one. Sophia? Oh no, Sophia, what's wrong with the denominators? Oh goodness, what do we need to do? And what will they be? Well, what will all the denominators be? They're all going to be 6, and the new numerator for A is? And the new numerator for B is? That's right, because 3 goes into 6 2 times, blah, blah, blah. Okay, now, what do I do? Not yet. We got to place them all in here. This is reduced. We're taking it from here to radical. So tell me, first, what do I do with the 6s? The checky thing? All right. Now what?
7 in the first thing, A with the power of 3, and then B with the power of 2.
There you go. And you're done. Good job. Any questions? Valeria, any questions? Miranda, anyone? All right, last one. I have 3 to the power of 3 over 8 times r to the power of 1 over 4 times s to the power of 1 over 2. Morgan, redeem yourself.
I thought I had, but I'll do it again.
Okay.
So you've got to find the common denominator, which in this case is 8. So 3 and 3 would stay the same. R would be turned into R and 4 eighths. Or sorry, 2 eighths. You see the 1/4 there. And then S would be 4 eighths.
Okay, so you've got common denominators.
And then you put them in the checky boxy thingy. 8 would be in the checky. And then you put 3 to the power of 3 times R to the power of 2 times S to the power of 4. Then you box it.
Nope.
Done.
What's
How do you
3
know that?
cubed?
Oh, right. That would be 27.
Guys, make sure if your number has an exponent that you go ahead and work it out so that it's complete. Okay, Miranda?
How do you know what to reduce?
The only time you're reducing, there's no reducing here because there's no fractions, right? That's up here. When you're going from the radical to exponential, if these needed to be reduced, you would. But here we're going from exponential to radical, and there's no simplifying. Any questions? Y'all got it? All right, let's run with it. You are doing page 435 to 436. $15 problems. 2 through 20 even. And 30 through 38 even. They are due Thursday. I'm forgetting what day it is. They're due Thursday.
Friday. Let's do Friday.
I am not doing ooh, I should do some. No, I'm not gonna do it. I'm gonna be nice since it's exam week and there's no honors problems, and I'm also not assigning IXL right now. But if you want to know what I'll be assigning, I can go ahead and let y'all know that if you want to get a jump on it.